Alright guys, now in this video we'll be taking an example on power series solution, and we have our example to be there. Now what we do is we make y equals to the sum of a's of r s raised to power r. When we differentiate it once, we have it to be r a r s raised to power r minus 1. When we differentiate it twice, you see that the sum is starting from 0 when it was not differentiated, it's starting from 1 when we differentiated it once, and it's starting from 2 when we differentiated it twice. Now substituting back everything, we have it to be 1 plus x squared sum of r minus 1 and all that up to 6 a's of r s raised to power r. Now when we open the bracket, you notice that all the term apart from the first term is having s raised to power r minus 2. So we'll look for a way to linearize everything. You see that the first one is having s raised to power r minus 2, the second one is having s raised to power r, the third one s raised to power r, the fourth one s raised to power r. So we look for a way to linearize everything by substituting r plus 2. Now if we substitute r plus 2 in that first line, in the first part, you will see that r minus 2 will cancel out. So and r equals to 2 also will change to 0 automatically, because if we say r minus 2 is equals to 0, but we already said that let r equals to r plus 2. So it means that r equals to 0 is going to cancel out. So we have our new expression to be r equals to 2 r minus 1 h of r s raised to power r plus 2 r plus 1 a is of r plus 2x raised to power r. So that's that other part. Then you bring down the other line. Now you equate at r equals to 0 and r equals to 1. That statement is very important, so you have to put this statement there to linearize everything. You see that the summand is having r equals to 0, r equals to 2, r equals to 1 and r equals to 0. So we have to look for a way to linearize everything by saying that r equals to 0 and r equals to 1. Sure you get. Now if you put r equals to 0 and r equals to 1, you substitute. We have it to be 2a2. Where is the 2a2 coming from? 2a2 is coming from when we put r equals to 0 and r equals to 1. So we have it to be 2a2 plus 6a3x plus summa of r equals to 2. The next summa, you can see that we also have it to be r equals to 2. The next one, r equals to 2. So what you should be after is to linearize everything. You can't have r equals to 0 at one part and have r equals to 1 at the other part, and you can't have s raised to power r at one part and be having s raised to power r minus 2 in the other part. So you do your best. In power series solution, everything must be in accordance, everything must be in order. They must be of the same pattern before you can proceed and do anything. So look at it. Take a look at r equals to 0 and r equals to 1. 6a3x. When we put r equals to 1 in the last line, we have it to be 6a3x. So that's where 6a3x is coming from. Now we are not done. We have 2a2 plus 6a0 equals to 0. Why? Because we equate those ones that have the same terms together, and we make a2 the subject of the formula. Also you see that we have 2a1 and we subtracted, we have minus 4a1x and we have 6a3x. So 6 minus 4 will give us 2. 2a1 plus 6a3 equals to 0. The reason why we equated them together is because they have the same x. They both have x. You understand? So we make a3 the subject of the formula. You understand? Now we equate all the sum together and we factorize out s raised to power r. You understand? We factorize s raised to power r. Now in cases like this, well, the next thing to do is to open the bracket and make ar plus 2 the subject of the formula. If you open the bracket of r minus 1, all that, you have it to be, it will give you a quadratic equation, that's r plus 2 r plus 1. You understand? So you make ar plus 2 the subject of the formula, and that is called our recursive formula. Now we start from r equals to 0, r equals to 1, r equals to 2, r equals to 3, r equals to 4, 5, 6. Now let's stop at r equals to 3. Now a2, we are not putting r equals to we already have a2, a3 initially before, so we now have a4, a5 now. So to finalize our answer, we recall that from power series, from the first video I made on power series, if you've not watched the video, kindly check my details or my playlist on differential equations. You see it there. So from y equals to summa of a naught s raised to power r, we have it to be a naught plus a1x plus a2x squared plus a3s cubed plus a4 s raised to power 4. Now we have we are dealing with a naught and a1 now. You understand? So you see that all the terms are between a1, a naught and a1. So we bring everything together, we factorize out, and we have our final solution. Thank you.